Liskov substitution principle means we are in kind of a discussion about design principles and the typically solid SOLID. There are five design principles that is globally accepted and uh, solid will start with single responsibility. We talked about open close. Now L is Liskov substitution principle. Okay. So what is Liskov substitution principle? If I write a code with a class, okay, like I am developing an algorithm, and inside the algorithm I have used a class called sort algo. Okay, so sort algo probably it may do many things, but main idea of sort algo is doing the sorting. So if I have written a function, and in the function, if I have used a class, I mean through class pointer only, through I have used a class, then that class should be substituted. Okay, this is called uh, a substitution principle. Okay, LSP. So if I should be able to replace that class with any of its derived class. So I have written an algorithm. Inside the algorithm, I have used a class, means class instance. Through the pointer, I have used method. So wherever I have used this class, okay, if I have subclass of it, okay, so if there is a class called sort algo, if I derive five classes from sort algo and I give the object pointer in the function replacing whatever the sort algo pointer is, then it should be able to completely replace. So parent class, base class should be completely substituted by or replaced by the derived class. So that is the concept. If that is the true, then it is should be considered as it follows the Liskov substitution principle. Means it follows a designing concept so that the workout what has been done, so that is open for extensibility and close for open for extensibility and close for modification. So whatever we have written algorithm, whatever the function we have written, if function is using any class object pointer somewhere, that class object pointer should be completely substitutable by its subclass. So if I have a function called func and func take the pointer as a sort algo, and with sort algo class object I have written the code, then sort algo A comes into the picture tomorrow, then I should call the func with sort algo A object and it should completely substitute wherever sort algo is there. So this is LSP. So Liskov substitution principle very powerful. Means very powerful in the sense of open close principle. Now the function what I had written that is using a sort algo algorithm methods. So that function is as it is. So whoever has used sort algo class object, okay, thousands of places, 10,000 of places, nowhere it should change. Okay, so this is a high reusability concept. So design principle mainly comes with the reusability only. So it follows open close. If we talk, then internally it think about LSP, and if I think about LSP, it thinks about the open close principle. So that is the concept, that is the idea. When breakage would happen, like if I have written a function and there I have used sort algo. So in the market tomorrow means sort algo I have written. Sort algo probably it's a insertion sort. Okay. But tomorrow a very nice algorithm came that is called quick sort, and then And again, a nice algorithm came that is called heap sort. Now, from the sort algo, I derive the quick sort, I derive the heap sort. Okay, so it depends upon, because quick sort, the worst case scenario can be n square. So depend upon the scenario, I pass the quick sort or I pass the heap sort a class object. Since they derive from the sort algo, so in the function, wherever I have used the sort algo class object pointer, it should be completely replaceable by the quick sort or heap sort. So that is the concept of LSP, liskov substitution principle. So this gives us a freedom to write a kind of abstract kind of algorithm, or think abstract kind of function, and then in that way we have the everything implemented, and it is now substitutable, so it is extendable. Whatever class we have used in the function, that class is now substitutable, replaceable by any future class who is derived from it. So it is defined in a term that if t is a class, so that this is the principle. If T is a class and of class T there is a object A, and there is S is a class which derives from T, and I have written a function based upon A, then T's object, that is B. So T's object is A, S derives from T, so S object is B. So B should be able to completely substitute the A wherever the A based algorithm is written. Okay, this is one thing. Second thing is, now we talked about insertion sort, because I had that sort, insertion sort. So first we'll talk about where it would fail, and other thing is interface fail. Then we'll talk about obviously the design pattern. So it is kind of where it would fail. Like if I have used insertion sort. Okay, so sort algo is insertion sort, and if I call sort function there and pass an array, it returns the sorted array. But if I use quick sort and pass an array, it does the sorting implement. This is how it is. So it is breakage, because the actual sorting is that it takes the array and return the sorted array. Whereas from the sort algo, if I derive and then it takes the array and it do the in place sorting, it doesn't return anything. Okay, if that is the case, so whatever the return type the base class conforms, so same return type it should also do. If there is a change in return type, so base class should return a polymorphic object, and this should follow the polymorphism. So as per our principle, okay, the way we have placed our open close principle, that if we write a algorithm, write a function using a base class, and we expect it is open close principle, then whatever function we call, please make it polymorphic. Okay, use the either interface if it pure interface if it is possible, or use it polymorphic. We have given example of football in the kind of open close principle. So if if the sort algo returns sorted something, then if derived class returns different kind of object, that object should be polymorphic. It should derive from the return type of the sort algo. Sort returns an object, then the quick sort should return an object that should be derived from the parent one. So idea is that we have, whatever we are using uh, um, the base class pointer and return type and parameter what it takes, the derived class should have equal parameter or less parameter. So it should be more restrictive, and things should be polymorphic in every fashion. One thing. So if I am writing code with a sort algorithm, that is insertion sort, why not to write code with pure return? So if I have a function and then I'm using sort algo, and there I'm calling sort algo is internally injection, because I thought that this is the de facto sorting algorithm. Who knows that tomorrow quick sort and then heap sort would come. Then I have the function written with the concrete class, even though it is a base class pointer, it is a concrete class. Nice to have an things written with the interface class. From there, it to derive insertion sort, quick sort, and heap sort, and whatever comes into the picture. So this way, the coupling between the base class and derived class, as far as implementation is concerned, would not be there. Okay. So when we write something, then please use the pure interface, and then in the liskov substitution principle also, please substitute with the implemented class. Okay. So rather than sort algo, that is the insertion sort algo should be the pure interface class. So that is a concept that should be followed. So we talked about what can be limitation. We should break this. So one is that function is less restrictive. The base class methods are more restrictive. Derived class methods, they need more parameters as function parameters. They return something different that is not polymorphic, or they raise some exceptions. So their behavior is different. It's a tight behavior. It's a kind of a strict behavior type. We can say this. So the derived class behavior, internal behavior is also different. Many places it raise exceptions that base class. So if base class is pure interface, then raising exception or those things doesn't come. Okay, so nice. So when we write any function and we use base class pointer, please use interface only, pure interface. And then derived classes should conform to the base class methods, and they should be exactly substituted. So the base class methods parameter return type, derived class methods return type, derived class should be more restrictive. Number of parameter, type of parameter should be derived one, and it should be less. Okay, so now puzzle comes. So Liskov substitution principle, it follows which design pattern? So it follows strategy design pattern. So this is a strategy design. We write a function, okay, and then there we use interface classes and their methods, and then at runtime, so we to take those interface classes or base classes as pointer the parameter to the function as a strategy, because we create a strategy. When we create a strategy in a function, we write with the base class, we call all the methods and we can make a strategy. In the strategy itself, probably we may see sorting. So there we talked about sorting. So this is strategy design pattern. So in strategy design pattern, function is written with uh, a base class pointer that we receive through function parameter, and through base class pointer we receive all the methods. We write all the method in a way that it fulfills our functions science functions logic, and that base class pointer object, real object, we pass at runtime. So base class pointer, it is advisable that please use interface. So this is Liskov principle, where base class pointer object in any function algorithm is completely substitutable by derived class derived class objects. If it is not completely substitutable, then it is not following the principle. Like I have a vehicle and I have methods like put petrol and then start the engine, take the accelerator. Okay, now from the vehicle I derive car. Okay, petrol car, petrol bike. In case I derive the diesel car, then diesel car, if I call a function put petrol, then it would not work because diesel car will not put. So here we are breaking the LSP, Liskov substitution principle. Or if I have electricity car, then there also put petrol would not work. So I can say put fuel, Probably it may work because electric car as a fuel they will recharge through electricity. So two things. One thing is that whatever the base class we have written, we take care that derived classes should conform to it. They should not raise any unwanted exception. They should follow the signature of the method. And second thing is that the base class should be written in a base class which should use as interface only. If we use concrete base classes, then the functions what we call should be polymorphic. So they should be classes, polymorphic classes itself, not the concrete functions. The way footballer example we saw in the open close principle. So if we follow these concepts, then new principle liskov substitution principle, so nice, so clean, and life is easy like a vehicle.